How's it going, y'all? This is the LagFoundry here. And in this video, I thought I would give y'all a tutorial of the lighting circuit that I used in my other video. I guess let's get started. You want to start off by placing one memory cell, and then 4 branches on each side of the memory cell. Get your blocker, place 2 of them, get out your splitter, place 2, timer, and then counter. Get on there. There we go. And then one more branch for the output of the counter. Like I said, some of you might look at this and recognize the makeup, and that's because, yeah, this is kind of sort of similar to the turret toggle circuit. I'm very tidy about my wires, so if you don't mind just me taking a little bit of extra time to, make them look neat. Making it look good goes a long way. So you want to take the power inverted and the power out and hook them up like so. Run the chain up your branches. Now you're going to want to grab, make sure that's set on 2. Take the branch out into your blockers. Take the power out of your blocker into input of the splitter. And then we're going to take the outputs of the splitters, make sure you go from power out 3 to the block pass through the blocker. And then the toggle will go to power out 1. Now, for this branch, set it to 1. Take the branch out to the power end of the splitter. Not splitter, timer. Come on. There we go. Now take the power out from the timer into the increment counter of the timer, of the counter. And now take the power out from the counter into the branches that branch out into the counter as well. Set this to 2. Now we're going to take the set node of the memory cell into the power out and the reset node power out and the clear counter into the branch out. Now this part isn't terribly important, which one you hook it up to, because power out, branch out, it's not going to matter on these 2 branches because they're both outputting 1 watt. But the important thing is just you're setting and resetting the memory cell and clearing the counters when it switches. Set your counter to the specified number as well as your timers. And then there you have the first part of the circuit. it should switch over back and forth. That's why. Should switch back and forth, like so. Alright, for the next part of the circuit, get yourself 2 branches, memory cells. And then 2 branches for each output of the memory cell. Hook them up like so. It's going to be your power inverted to the first ones, and then the regular output to the second ones. Oh, that looks bad. Let's straighten that up a little bit. There we go. Set them to 1. And then you're going to want to take, this is how it's going to switch back and forth. It's going to go this branch, then this branch, then this branch, then this branch. That's going to be the order of power. So you want, since this is going to be the second one to turn on, you're going to want to take the output from this one and set it into the set node of this memory cell, and the branch out of this one and set it to the reset node of the memory cell. And then for this one, it's going to be backwards, because you don't want this setting this when this is the first one to activate. That means the power inverted on this will never get a chance to go off. So instead of setting this one to this, you're going to set this one to the reset. Matter of fact, let's go ahead and hook this one in first, just to make it look a little bit tidier. And like so. Now you can take the power out from your first branch over here into the memory cell, and then power out from this branch into that memory cell. Now when you hook it up, you should see it flip back and forth, just like that right there. Now for the next step of this, you're going to want to use OR switches, because once it gets past this point, it's not keeping the last memory cell on long enough to have the other memory cell set it. And so you're going to want to use OR switches to keep the previous one powered on just for one more step. So grab yourself 4 ORs. 4 ORs. 4 memory cells. And then just like over on that side, you're going to want 2 branches off of that one. Now in the video I have these branches on the side right here, but truth be told it doesn't really matter. You can put them under the OR switches if you want, which I'm going to do now, just so that way you can, makes it a little bit more clear what's going on. So remember, this is going to be 1, 2, 3, 4. So you want to hook it up to your branches over here like so. Make sure this is the right color. There we go. Now if you're wondering about my colors, I usually use red for main power, orange for branched out power, and then blue and green for logic. And I guess I use black for main power as well. So now, yeah, when it lights up, it should be 1, 2, 3, 4. And so you're going to hook it up to your OR switches like so. Don't forget to set these to 1. And now here's the important step. Since you want this one to stay powered when this one powers up, you're going to take the branch out from this one and hook it up to the input of the last OR. And do the same thing all the way over. And then take the branch out from your first one and hook it up to the fourth one. So that should give you this right here. Let's bring it up. I don't know why OR switches that big. Like, you have to get under them sometimes to get a clear highlight of the node. Face punch, fix that, please. Now set all these branches to 1. And then pretty much do the same thing with these branches how you did over here. And then just like with the first one, on those 2 over there, you're going to take the outputs of this one and just basically reverse them. And then there you have it. But yeah, guys, that's basically it. You have the turret toggle circuit as the pulse generator. And the reason I like to use this variance is because the wide range it has on timing. Since you can set the time on the counter and the timer. And then you just keep splitting it like so with your memory cells. If you wanted to do 8 memory cells off of this one, you would still hook them up the same way. And just like the name implies, exponentially, you can just keep exponentially increasing it.